13.2 is using exact values and angles in the unit circle. So we're going to referring back to the unit circle, which we did in geometry, of the unit circle being a circle with a radius of 1 and centered at the origin. So each one of these ordered pairs around the circle are going to be represented by the cosine and sine of the angle, where the cosine is the x and sine is the y. So this ordered pair, if this angle is 120 degrees, then this ordered pair would be the cosine of 120 and the sine of 120. So in order to do that, I want to review the special right triangles. So there's two special right triangles. Notice how both of them have a hypotenuse of 1. That's going to be your radius in the unit circle. So in a 30, 60, 90, half is going to be across from the 30. Root 3 over 2 is going to be across from the 60. And then the 45, 45, 90, since it's an isosceles triangle, these two sides are going to be the same and they're root 2 over 2. So cosine and sine of an angle. Suppose an angle in standard position has, so standard position means that the angle is created by a ray that starts at the origin. So suppose an angle in standard position has a measure of theta. So that's just a degree measure. It's a variable. The cosine of theta is the x-coordinate of the point at which the terminal sides intersects the unit circle. The sine of theta is the y-coordinate. So just kind of what I showed over here, I'll go over that off to the side again. Any point around the triangle, around the unit circle, can be represented by the cosine of the angle and the sine of the angle. So example 1, use the unit circle to find each value. So recognize that cosine is the x value and sine is the y value. So I'm going to make a unit circle right here just to refer to it. So if this unit circle has a radius of 1, this ordered pair must be 1, 0. This ordered pair must be 0, 1. This ordered pair is going to be negative 1, 0. And this ordered pair is going to be 0, negative 1. So in a circle, if the circle is 360 degrees, this is 90 degrees, this is 180 degrees, this is 270, and this is 360. And also 0. And it keeps going. It's going to keep going. So if I started right here and I went all the way around, 360 plus another 90 would be 450 plus another 90. You could keep going. So if I'm going to find the sine of 0, this means I'm going to find the y-coordinate at 0. So at 0 degrees is right here. The y-coordinate is 0. So the sine of 0 is 0. The cosine of 0 is the x-coordinate, which is going to be 1. The cosine of 90 is going to be the x-coordinate, so that's going to be 0. The sine of 180 is over here, the y value is going to be 0. The cosine of negative 270, so you're going to start right here and go down 90, down, up 180, 270. So the x value, which is cosine, is going to be 0. So if you have negative angles, you might remember from geometry, you're going down. So sine of negative 90 is the y value at negative 90, so it's negative 1. So example 2, find the measure of an angle between 0 and 360 that's coterminal. So it's another way to write the angle of each given angle. So your answer needs between 0 and 360. So if I have negative 100, I'm going to start right here and go down past 90. So what's another way to get to that angle? Well, I can go up positive 260 degrees. I went 260 because that's a difference of 360 and 100. So 260 is the answer. If I did negative 60, so I went down 60. What's another way to get there that's positive? So if I went around, it would be 300 degrees. Okay, negative 225 is going to be go 180 plus 45 more. So another way to get there is to do 135 degrees. Okay, 450 is going around the circle 360 and then another 90. So really, to get this angle, you could just do 90 degrees. Negative 600, start right here, go around 360, plus go 90 more, so that's 450, plus go 90 more, so that's 540, plus go 60 more. So really what you're doing is you could go 180 plus 60 more. So 180 plus 60 is 240. Okay, you also should be able to do the exact value of cosine, sine, and tangent. Okay, so what you want to do is draw this in the unit circle. So draw a 45-degree angle. And you always bring down your triangle to be perpendicular with the x-axis. So if this angle right here is 45 degrees, I'm going to fill in the parts of the unit circle. So I know that this is 1, this is root 2 over 2, and this is root 2 over 2. So the cosine is going to be the x-coordinate. So if your coordinate of the unit circle is right here, your x has went right root 2 over 2. So the cosine of 45 is positive root 2 over 2. The sine is also going to be positive root 2 over 2 because you went up. Now, to find the tangent, you could do opposite over adjacent. So opposite over adjacent would be root 2 over 2 divided by root 2 over 2. So the tangent of 45 degrees is going to be positive 1. So tangent, another way to look at tangent is tangent of theta of an angle is sine of theta over cosine. Okay, or the y divided by the x. Okay, I'm going to do 225. So 225, I'm going to draw a 225 degree angle. So it's going to be right here. And that is going to be a 45, 45, 90 again. So I'm going to label this as root 2 over 2 this distance, and this is this is root 2 over 2, the distance. So if you're looking at the cosine, the actual coordinate right here, the x coordinate is going to be negative. So the cosine of 225 degrees is negative root 2 over 2. And the sine of 225 is also negative because you're going down. You're in the third quadrant. So the sine and the cosine are going to be negative. The tangent of 225 is either going to be, you could do the sine over cosine, or you could do the opposite over adjacent. Both of these are negative, so it's going to be positive 1. Okay, now I'm going to do the sine and cosine of negative 225. So remember, if you have a negative angle, you're going to go around right here, drop it down perpendicular right here. This is a 45. So again, I have root 2 over 2, root 2 over 2. So the cosine, because I went left, the cosine of negative 225 degrees is going to be negative root 2 over 2. The sine of negative 225 degrees is going to be positive root 2 over 2. And then the tangent of negative 225 is going to be opposite over adjacent, or sine over cosine. In this case, since the cosine is negative and the sine's positive, or the x is negative and the sine's positive, it's going to be negative 1. Okay, then 330. So I'm going to make 330 degrees is going to be 30 degrees short right here. So this is my 90, 30. So in a 30, 60, 90, opposite the 30 is 1/2, and opposite the 60 is root 3 over 2. So my cosine of 30 is going to be adjacent over hypotenuse, so it's going to be root 3 over 2, or the x value. Oops, this should say cosine. It's going to be positive because I'm going right. The sine of 330 is going to be negative 1/2 because I had to go down. And the tangent of 330 is going to be opposite over adjacent. So, or sine over cosine. So it's going to be 1/2 divided by root 3 over 2. So this is a complex fraction, so we can just multiply by 2 over root 3, which will give me 1 over root 3. And now I want to rationalize this. So this is going to be root 3 on the top and the bottom. It's going to be root 3 over 3. Because the sine is negative and the cosine is positive, the tangent's going to be negative because there's going to be a negative divided by a positive. Okay, example 4, find the measure of each angle in standard position. So instead of going 60 degrees down, this is just going to be 300 degrees. And here it's showing this is 60, so how do we make the 60? Well, it's positive 180 minus 60, this is 120 degrees. In this one, I'm going all the way around the circle short of 45 degrees of 360, so it's going to be 315 degrees.